Okay, today we're going to look at logarithmic graphs and see what they look like and talk about the fact that they are inverses of exponential functions. So the first thing we want to do is look at these two as inverses. So if you remember back last semester, to find the inverse of an equation, we had to switch x and y and solve. Okay, so to look at the graph, if you have this dotted line here, and this dotted line is your y equals x, okay, that's y equals x, goes through 0, so there's no y-intercept, but you can see how 1 reflects across that line, and it doesn't matter which type of equation it is. If you have just two lines, the inverse, switch x and y. If you have a quadratic and you switch x and y, the inverse of x squared, you can see, is the square root of x. If you do the positive and negative square root, it gives you that whole curve there. But again, you're switching the x and y and solving. You can look at all different types of functions, and I'm just showing you a couple graphs here just to get your brain thinking about what the inverse looks like. So again, this green line here is your y equals x. And if you have this red function f of x, the inverse would be the blue g of x function because you flip or switch the x's and y's. The next one is x cubed is the inverse of cube root of x. And then here at the end, you've got kind of like an exponential function and a logarithmic function. So it doesn't say that, but you're going to see that's kind of what we're getting ready to look at. So to graph these, it says to use your graphing calculator to sketch the graph. So if I want to sketch the graph of log of x, using your graphing calculator, if you turn this on, let's do clear here. I've already got these in here, so I'm going to clear these out and then go back and start over. So here we've got f of x equals log of x. So I have a log button, base 10, log base 10 here on the side, so I've got log of x, and I hit graph. And you can see it's it kind of comes up and goes across here, mostly in quadrant 1. So if you go second table, you can see as you go up past 0 that there's an error. Okay, so let's look at the inverse function. Let's look at f of x equals 10 to the x power. So 10 raised to the x power, that's your exponential function. That's the inverse of log base 10 of x, and hit graph. All right, if you remember the exponential function, it grows very quickly when it's exponential growth. Okay, so if you remember when we talked about exponentials, it had an asymptote here at y equals 0. Now the logarithmic function will have the same thing, except it's going to be x equals 0. So this tells us to simply sketch the graph of the logarithm. So it's just going to be a rough graph. It's going to look something like this. And it's going to approach this line, but it's not actually going to get there. All right, and the exponential function, it grows very quickly. And if you remember, the asymptote is here. All right, so just looking at what those look like and how one is the reflection of the other across the y equal x. All right, so if we talk about the parent function, okay, what is the parent function of a logarithm? So the parent function is going to be log base b of x. Okay, and we can say this is f of x equals log base b of x. All right, if you remember, the parent function for exponential was g of x equals b to the x power. So some b to the x power. So this was exponential. And this is your logarithmic. And remember, a parent function is your most basic form of a function. Okay? All right, guys, so looking at the graphs of an exponential or logarithmic function, we're just going to look at the calculator and use that. So we're thinking about these two being inverses of each other. You could graph an exponential function, switch the x and y's, and then graph the logarithmic function. But almost never will you have to have a graph of a logarithmic function. Just knowing the basic look is the main thing. So I'm going to show you how to sketch these quickly using your calculator. And the main thing is being able to find the key characteristics of this. So on your calculator, if you have a TI-84, if you use the LOG button, that's only base 10. Well, number 1 here says log base 2 of x. So we need to graph this logarithm using base 2. If you have the updated version of the TI-84, if you click on Math and you arrow up or down, you're going to get to something that says log base. So hit enter and it will allow you to enter a different base in. So again, don't use this button unless it's base 10. Go to Math and click on log base. So I'm going to click on log base 2 of x. And then I'm just going to sketch my graph. Okay. All right. So I just need to have a general shape of my graph here. I know that it is approaching this line here, as we talked about before. The exponential, the isotope was here. And with this graph, the isotope kind of goes up and down. So especially with most of these, I can't draw a straight line here, but I'm trying. All right, so there you go. And so the graph approaches this line down through here. And just kind of looks like that. All right, so the isotope here this time is going to be x equals 0. Before it was y equals 0. Now it's going to be x equals 0. All right, the x-intercept is going to be, it looks like it's 1, but you can go to second graph and hit the table, and it shows that your intercept there is 1, 0. So for this, I'm going to put 1, 0. And then the domain. The domain is going to be everything from the isotope this direction. So before the domain was all real numbers, now it's only the positive real numbers. So you can say it goes from 0 to infinity. And the parentheses shows that 0 is not included. If you look at the calculator, 0 is an error. So it's going to be actually, it goes up to 0, but it doesn't include 0. Now the range is your y values. So it's going up with the arrow and down with the arrow. So it's still negative infinity to positive infinity. And in behavior, what does x do as y goes to infinity? So x goes to infinity as f of x, or y, goes to infinity. Okay, so that's this direction here. All right, as x approaches what? So x isn't going to negative infinity, it's approaching this isotope here. So as x approaches 0, f of x approaches negative infinity. It's going down with an arrow. So that's how you would sketch the graph and find the key characteristics there. All right, for number 2, we've got the logarithm of base 1/3 of x. So again, I'm going to go to Math, and I'm going to scroll up till I found my log base button. And I'm going to type in 1/3 by doing 1 divided by 3. And then I'm going to come over and put an x in. All right, so when I graph this, to think about what it's going to look like, it's going to be the inverse of the exponential function 1/3 to the x power. And if you remember, when your base is between 0 and 1, for exponential, it's exponential decay instead of exponential growth. So hence that would be why it kind of goes down, because a logarithmic function is the inverse of the exponential function. So a lot of information, but just trying to make you visually think about what that's going to look like. So we're going to sketch this graph. And again, I'm going to have my isotope for my logarithm. Unless I tell you different, it's going to be, unless it gets shifted, actually, it's going to be x equals 0. So I'm going to go ahead and put x equals 0 here. And we can check the y-intercept again, but it does look like our intercept is 1 again. So 1, 0. And the domain is going to be 0 to infinity. And the range is going to be all real numbers. All right, now what happens as x goes to 0? F of x goes to positive infinity. So this goes up this time as x goes towards 0. And as x goes towards infinity, f of x goes towards negative infinity. Okay? All right, so being aware of what the end behavior, the domain and range, the intercept, and the isotope, those are important things to know. And again, just sketching these in your calculator is an easy way to look and see what these are. Again, on the EOC, you won't be asked to graph anything without a calculator. I've never seen a logarithm equation on ACT that you would have to graph, and outside of Math 3 and trigonometry, I'm not sure when you would ever use a logarithmic function unless you become a scientist. So there's no point in spending a ton of time graphing these without your calculator. All right, let's look at one more quickly. So go to number 3 and go to Math. Let's arrow up to log base. We're going to do log base 4 of x minus 1. This time it's going to be shifted over 1. We're going to hit graph and then sketch that graph. You can see there it looks like this time the x-intercept is at 2, and that's because this has shifted it over. It was at 1, we shifted it over, now it's going to be at 2, 0. All right, so sketch the graph here. All right, we already looked at the intercept, so let's go ahead and write that down. Intercept is at 2, 0. This time it is approaching 1. So this time, because we shifted it over, that means the isotope is also shifted over. So that's going to make the isotope over 1 as well. So x equals 1 this time. And the domain, again, it's going from this line, your isotope line, over. So the domain is going to go from 1 to infinity. And the range is going up and down both directions with arrows. So that means all real numbers. And then the end behavior is going to be as x, when f of x goes up, x is going towards positive infinity. And as x approaches this number 1, y is going to negative infinity. So that's again how to sketch the graph and look at basic key features of a logarithmic function.